All right, well, welcome everybody. My name is Jesse, and I've been at Apollo for about 4 years. In my past life, I was a software engineer. I've written lots and lots and lots of APIs. I've had to tune and scale APIs. I've had to implement caching in all different sorts of ways. And so that's what we're going to be talking about today. We're going to be talking about how we actually optimize performance of your supergraph. And we're not just going to talk about entity caching, even though you just heard Matt talk a little bit about that in the session prior, but we are going to deep dive into entity caching and show you some really cool stuff. So let's talk about the agenda. First things first, we're going to talk about caching 101, which is just kind of like talking about what are the differences, what are the similarities between caching with GraphQL in your infrastructure and caching with, let's say, REST or something like that. Then we're going to talk about how we actually optimize our stack, and we're going to start at the domain layer, which is close to the data. We're then going to move to the middle, which we can call like the routing layer. That's where we're going to focus on entity caching. And then we're going to talk about the edge. And so we're going to talk about a little bit about CDNs, a little bit about clients. So, caching 101. Let's talk about how we actually do this. This is going to be a review for most of you, so we'll breeze through it pretty quickly. So caching with HTTP. Caching with HTTP is relatively straightforward, especially from a origin server and a proxy standpoint. We've got some headers that we can use in order to define how those intermediary proxies and even the browser or any of our devices actually handle cached data. The primary one that we're going to be talking about today are cache control headers, which, there's a lot of complexity in cache control as a header, but we'll specifically be talking about things like max age. There's other, obviously, cacheability headers that we can dive into, like if modified sense, etag, all that kind of stuff. But for today, we're going to be specifically focusing around cache control. So, that being said, caching with REST. So, caching with REST is actually pretty easy because REST is just HTML and it's just HTTP. And so, HTTP is going to have a server that's going to generate some sort of response based on an HTTP request. There might be intermediary proxies, CDNs. They're going to be able to cache that content based on the cache control headers that are returned by the origin servers. And then our devices, our endpoints, those will also be able to cache that data. This is how whenever you press reload on your browser, you get a really snappy response because your browser is going to be able to cache those assets for a certain amount of time based on the cache control headers. Now, where caching with REST actually gets more complicated is whenever clients have to orchestrate multiple different calls to multiple different microservices. And each one of those microservices might have a dozen, 100 different REST resources. And each one of those could return a different max age or a different time to live for the content that it's returning. So what that requires is that within our applications, we manage those stale data expirations and be able to have enough logic in there to be able to refresh data whenever it gets, past its time to live. So this puts the onus on the client. The client has to have this complexity either through a really nice library that you're using to manage all this, or you have to actually manage all of this yourself. And when you're coordinating requests across a, let's say, endpoint A that then gives you the IDs that you need to call endpoint B and then endpoint C, this can become more and more complicated. So how do we do this with federated GraphQL? Now, you'll notice that I'm skipping how do we do this with GraphQL because GraphQL is just HTTP. If you have multiple different GraphQL servers, each one of those, in response to a particular data request, could return back different cacheability information in the form of headers. With federated GraphQL, things are a little bit more interesting, and at the onset, we can maybe think that it actually restricts the ability for us to cache information, but what we'll see is that's not the case. So in federated GraphQL, we've got in the middle here a router, like the Apollo router, and then behind that we've got various different domain services that ostensibly talk GraphQL, or with REST connectors, we can directly wire into individual REST resources. But what happens here is that the browser, or whatever client we have, is going to issue a GraphQL operation against the Apollo router. That GraphQL operation, once we query plan it, might actually contact multiple different downstreams, or upstream servers in this case. It could be one, it could be a dozen, it could be 100. And there could be follow-up joins that happen in order to piece together all the information we need in order to satisfy that particular GraphQL operation. Now, the way that cache control headers interact with the Apollo router is that each one of these different services, in response to an upstream GraphQL request, can return a different cache control header. And it can set the max age to be a different value. So for instance, service A might have a max age of 10 seconds, service B, 600, service C, 3600. Now, what the router is going to do is it's going to analyze all those different cache control headers that are being responded by the subgraphs, and it's going to calculate the floor, right? That's basically as long as it says that entire composite response can be cached by any downstream proxies or the end device. So in this case, our lowest max age is 10 seconds, so that's what the Apollo router would calculate as the overall max age for a particular response. Okay, so now that we've talked about some very basic information about cacheability, let's talk about why it's not always a good idea to cache things. And we'll do this pretty quickly just so that we don't over-optimize too early. So when you might be caching too early, first is you're in early development. Starting to over-cache and start to rely on cacheability before your application's fully written and fully tested is usually a recipe for madness because you're going to have a lot of weird states that you're going to have to handle early. Best to have your application fully working and baked before you start thinking about adding cacheability on top of your applications, especially full response caching. So the next situation where you might be caching too early is before you've actually tuned your data access layer, right? If you are issuing in a loop 1,000 select statements and you're thinking cacheability is going to solve that particular problem, that might not be the answer. You might need to actually tune the way that you're accessing data first, then move on to caching. And lastly, before you've got a plan for load testing, make sure that you know what you want to test, what numbers you want to get to, have that in place, and start actually building that into your CI/CD workflow so that you can catch regressions on performance, those kinds of things. So then when do we need to cache? Well, when we're ready to scale. We need to make sure that we are able to test our numbers, plan for our numbers, and we can start implementing caching policies that actually allow us to hit those numbers. Another place where you might need cache, there are a lot of systems out there where we're querying huge amounts of data. These are like BI systems or OLAP systems where you might be processing terabytes and terabytes of data. Just think BigQuery or some of these other kind of systems that can analyze a lot of data all at once. A lot of times those systems are returning back data in seconds, not milliseconds. And so caching that data so that we can reuse it actually is very advantageous for us because we can have really nice customer experiences even though we're accessing a massive amount of data. For dashboards, this isn't particularly important. There might be also organizational reasons that you need to cache. So you might be in an organization where you've got multiple different business units. Each one of those business units might be kind of an island unto themselves. And what if you're a central team? What if you need to ensure certain SLAs for your centralized API, but have no way to influence any of these other teams you're working with? Those might be situations where you have to proactively create a cache control policy at a central point, like the Apollo router, in order to hit those SLAs and provide the experience that you want. And lastly, similar to siloed, you might be working with an external service or a legacy service, a mainframe. These are systems that might not have been touched in 20 years. There's no way for them to go back in and re-optimize. So you have to implement your cache, at a centralized location in order to keep that data snappy. So let's talk about caching across the stack. We're going to start by showing all the different places that with Apollo technology you can actually implement caching, and then we're going to work through a couple of different examples. So the diagram I have here, on the right-hand side, we've got various different services that might be backed by different database technologies. They might be backed by even further upstream REST services. And then moving towards the center, we've got our routing layer with Apollo Graph Router, and then we have our clients on the far left side. At each one of these places, Apollo has technology that can help you cache your data and keep it very fast and performant. At the client, we've got client-side caching. For edge caching, like CDNs, we have the ability to use APQs or PQs plus GET in order to cache with those CDN technologies. We have entity caching, which we'll talk about in just a second. We have APQ and query plan caching. We have data loaders, which help us implement memoization and bulk data access paradigms at our service layer. We've got the ability to annotate our schemas with cacheability information, which we'll show in a second. We'll have the ability with Apollo Server for you to actually do caching at the subgraph level as well. So you have a lot of different places that you can do that. I'm going to break up this entire graph into a couple of key sections: the domain or the data layer, the router layer, and the client layer. So let's start at the data. Data loaders. If you're not using data loaders and you're thinking about caching, hold up and go back and look at what data loaders can actually do for you, because they solve a lot of problems that are inherent with GraphQL, especially with federated GraphQL, where you might have follow-up joins, where you might be pulling a lot of discrete data all at once. A data loader allows you to batch together a lot of database accesses into one bulk operation and then pull all of that at once. It also eliminates duplicate ID fetches so that you're only fetching the data you need one time. Very, very important whenever you're writing GraphQL subgraphs. Another really cool thing that you can do in Apollo Server, and this support for this varies across other subgraph libraries, but you can add it to almost any out there, is the ability for you to actually annotate your cache control information on your schema. Now, why is this really cool? One of the reasons this is really cool is because many times that kind of information is buried in some middleware somewhere. You really don't have a good idea what logic is being used in order to set the max age, the TTL, for various different pieces of data. With declarative cacheability information, we can go in and we can set this information at the type and even at the field level. Now, with GraphQL, this becomes very interesting because if you have a GraphQL operation that selects a particular field that has very low cacheability, then you can automatically override the other cacheability that might be set at a higher level in order to make sure that each one of those responses is cacheable for the exact right amount of time. So for instance, in this particular example, my product type might be cacheable for 300 seconds, but the in-stock count is actually only cacheable for 30 seconds. And so if I select that, in my selection, I need to make sure that the maximum cacheability time is 30 seconds. Does that make sense? So now let's talk about entity caching, because this is some really interesting technology that we've got that we're kind of showing for the first time. So a GraphQL response, specifically a federated GraphQL response, is made up of many different segments that are coming from different upstream services. In this example, we've got three. We've got a user service that's returning some information, and so that's one of my top-level queries here. I have a product service that's returning some information, and then I have a trends service, which is aggregating a lot of BI data for me to show on my e-commerce website. Each one of those responses might take a certain amount of time to generate by the upstream services. The user service might be super snappy and return my data in 10 milliseconds. Products might be variable based on time of day. And the trend service, which is a BI-based, is going to be significantly longer, 300 milliseconds, but it's going to be a little bit more stable. So when we have all of these different services, what do? Well, entity caching actually allows us to cache the responses from each one of our subgraphs separately in a cache, which means that they can be reused as like Lego bricks. You can think of your overall response being a set of blocks of data. Each one of those pieces of data is associated with a particular request, but it's also associated with a particular cache control information. So let's say that we have a service like products where the stock information is changing rapidly. We might only want to cache that brick in our overall response for a few seconds. But things like the user ID, that might be able to cache that for hours or days or whatever, because that's just information that's not going to change very often. The trends information coming from a BI or an OLAP system, also not going to change very often, probably can cache that for a while. So let's look at a demo of this in action. Okay, so here I've got a New Relic dashboard for us to look at. Now, the type might be a little small for the people in the back, but I'll talk about what we're seeing here. So up top, the big graph is the overall response time for my API. On the row below that, we've got the response time for my individual different subgraphs. So we've got the product subgraph. You can see it's kind of sinusoidal, just based on time of day. There's different peaks and valleys. The user subgraph is pretty quick, 10 milliseconds about the whole time, doesn't vary very much. And then my trend subgraph, that my OLAP system, is kind of like a sawtooth pattern here, around 300 milliseconds. So what if we want to actually enable entity caching to see how this can speed up our responses that are coming back from our various different APIs? Well, what I have here, and I'll try and make this readable for everybody, is a demo that we hope all works very well and there's no bugs. But in this, I've got 3 different subgraphs, and they're super simple, but they're meant to show what the subgraphs, a sample of a subgraph might look like for each one of these different services that are serving back data to my Apollo router. So on the left here, I've got the product service, and so it's got a product type, and it returns a query called products, which is just a list of products. I have in the middle a user service where I can get a list of users, and I'm even using some federation specific SDL here in order to be able to relate products to users. And then finally, I've got over here my BI system, my trends. And so it's got a couple of different queries that we can call highest rated, popular, and seasonal. Now, as you can see here, I've also added a directive to this called cache control. This cache control directive, you could call it whatever you want. In an Apollo server, this is a built-in piece of functionality that allows you to annotate your various different types and fields and return that appropriate headers based on this declarative cacheability. So let's go back to our metrics real quick, and let's actually start with the trends subgraph. And so in order to do that, I'm just going to go ahead and annotate a couple of my fields here in my query type with cache control information. And let's set the max age to about 30 seconds for the seasonal products and 30 seconds for the popular products. Now, behind the scenes, what's happening is I've got all 3 of these services running with hot reload so that whenever I make a change to any of this information, they're automatically going to update, and they're going to start returning responses with that appropriate cache control information. Now, we also have, as part of the mix here with entity caching, a Redis server, which is acting as our in-memory data storage system. So let's go ahead and look at what that looks like within Redis real quick. So as you can see, and this is a little small, let's see if I can make it a little bigger. There we go. Within Redis, I now have a couple of keys showing up here. Behind the scenes, my router is being queried for information, as you could tell from that dashboard in New Relic. And then when I went ahead and I annotated that cache control information, my subgraph servers are starting to return those headers to the router, and the router is starting to cache individual pieces of those subgraph responses. So here we have one, which is a subgraph response. You can see here some information. This is from my popular query, and we have another one here as well. And you can also see here the time to live that's set, and it's counting down here in Redis. We can do this at a lot of different levels. What's interesting about entity caching is that it doesn't just cache entities, even if the name sounds like that would be the case. It actually caches subgraph responses and includes the entity responses for any kind of joins as well. So we have a lot of flexibility in using this. As you can see here, I've set this cache control information on the query, but I could have just as easily set it on a type or a field within a type in order to get back that information. Now let's go and check on New Relic, and if New Relic's not running super slow, we should be able to see some interesting observations starting to pop up. So one of the things we're seeing here is that our overall response time is starting to drop significantly based on that cache control information. So this is going to be our average response across a lot of different queries that are running on the system. So we can see that's happening here. Now another thing that you'll notice here is on the bottom right, this is the trends graph, right? The trends subgraph. We're seeing the data points actually start to space out. Why is that? Well, it's not getting as many actual queries anymore. So overall, the load on that particular subgraph is dropping. Only every once in a while, as you can see, it's getting hit in order to refresh that cache that's being held by the Apollo router. This is super cool. Now, down here at the bottom, I also have individual queries that I'm showing information about their performance. And so for these individual queries, I can see here that the get seasonal query has basically like flatlined, right? Besides a couple of spikes every now and then in order to, regenerate that response, our response time now is 2.7 milliseconds for those particular queries that are running. So that just shows you very quickly, like we can go in, we've got entity caching enabled on the router, we start annotating some of our schemas, we can see dramatic effects in terms of the response time for our queries, but also the load. And of course, load translates to cost for running our various different subgraph services. So let's move on. We've talked a little bit about entity caching. We talked about how easy it is actually to get started. We can set up a Redis connection. We can start annotating our fields and our types very quickly. Let's talk about some other key pieces that we need that are involved here. One of those is cache invalidation. Obviously, you can't have a cache without a way to invalidate that cache. Now, by default, entity caching expires content from the cache based on the TTL. And for some use cases, that's enough because you don't actually need to be able to manually invalidate data. But there's a lot of use cases that companies have where this is not the case. For instance, let's say that we have items that get deleted or removed from our inventory. Let's say we run out of stock or there's a price change. There's a breaking news update, and we need to go and we need to clear the cache in order to be able to show the very latest content. Well, we've got a response for that. The Apollo router entity caching system has an invalidation API that you can call to invalidate any of the data that you need to remove from the cache to make sure that it can be regenerated whenever it's next called for. It's a very cool API. If you're interested in playing with this, please reach out to somebody here at Apollo and we'll redirect you to the right person to play around with it. But it's very interesting stuff here that we have the ability to do because we can do invalidation not just by the ID of a particular piece of content, but also by the subgraph or possibly other kinds of combinations in the future. So now let's talk about caching at the edge. What kind of opportunities do we have with Apollo Router and Apollo Technologies to be able to accelerate things at the client level? Well, one of the really interesting things about Apollo is that our ecosystem spans all the way from the back-end services to the front-end SDKs. So the Apollo Client SDK has the ability for you to enable a normalized cache, which caches responses that are coming back from your GraphQL APIs and allows you to actually utilize those as entities within that normalized cache. This provides you the building blocks for some really powerful features. One of those features might be an offline mode. Let's say that you have an app or some other kind of device that needs to operate in situations where connectivity might be intermittent. Offline mode with normalized cache gives you the ability to write those kinds of applications. You can also utilize this type of technology for things like optimistic commits. So if, let's say, you're on a very high latency connection, but you want to show an update whenever someone clicks that button immediately, right? Not a long spinner, not kind of a pause in the app. Optimistic commits can allow you to do that using the Apollo normalized cache. Now, CDN caching. One of the great things about CDN caching and the Apollo router is that you already have all the tools you need in order to implement this particular use case. The reason for that is persistent queries. Now, there's two forms of persistent queries with the Apollo router. One of these is the traditional APQs, where the persistent query is generated at runtime. So a client can say, hey, here's a particular hash, give me back the persistent query, or execute the query. If you don't have it, I'll give you the query and you store it for me. That's one way of doing things. Apollo also has the ability for you to actually safe list queries ahead of time in order to provide an extra layer of security for your API. Now, the key thing about this is that these types of queries can be requested via an HTTP GET. And so we can do an HTTP GET with just a simple hash or some sort of unique ID to the Apollo router. The Apollo router will look up the appropriate query, execute it, and return the response to you. Because of that, and because it's being used as a GET, CDNs like Akamai and Cloudflare, they can actually get that response, they can check the cache control headers, and they can cache it appropriately at the edge. So, closing thoughts. Don't cache too early. Caching too early is only going to cause you pain and misery. Wait until you actually have a strategy, you have an app that's baked, and then start down that road based on your individual requirements. If you don't have to cache, you might not need to. Start close to the data, right? Implementing a normalized cache on your client before any of your APIs are optimized is not a smart move. Why is that? Never trust a client, right? Make sure that your API level is actually good. So, third, use entity caching for the middle layer, the routing layer. The reason for this, it works natively with federated GraphQL. It's extremely easy to set up, and you can get amazing performance in a very small amount of time. Lastly, edge cache as needed. If you don't need to go down that road, you might not. So keep in mind that your other tiers are your priorities, and then finally end at the edge and start your optimization. So that's all I've got for you today. I hope that you got a little bit of taste of what we can do end-to-end with Apollo and caching. Entity caching is a fantastic technology. I'd love to demo it to you. My entire team would. So please come up afterwards and talk to us if you want to see more in depth about how the system works. And thank you for your time.